The bone tissue could be organized into two main forms. The first is known as the trabecular bone, and in adult human, this is the way how like 75% of the total bone mass is organized. So we have some trabecules. Another name would be spongy bone. Okay, spongy bone or cancellous bone. So we have bone trabecules in 3 dimensions, in 3-dimensional space. They have cavities in between, various shapes. On the surface of these bone trabecules, you can find osteoblasts that are producing new bone. You can find osteoclasts that are resorbing the bone. Okay. You can find the vascular canals. Surrounded by the lamellae of extracellular matrix and layers of osteocytes. Closer to the surface of the trabecules, the osteocytes are usually organized parallel to the surface, forming the so-called circumferential lamellae. And here you get the spaces occupied by bone marrow. In the bone marrow cavities. So these are the bone trabecules. This is one of these bone trabecules. There are osteoblasts. There could be osteocytes. The balance between the activity of osteoblasts that are producing new bone matrix and the activity of osteocytes that are resorbing the matrix, they affect the bone remodeling. Okay? We have the vascular canals here. This is one of the small osteons. And here is another trabecule, or trabecula, or trabecule. Here are the lamellae. And this is bone marrow. There are bone marrow cavities. For now, we can distinguish the red bone marrow, which is made of reticular connective tissue, with dilated blood capillaries called blood sinusoids, which are highly permeable, and they are hematopoietic cells. And there is also yellow bone marrow, which is mostly adipose tissue, white adipose tissue. The bone tissue could be also organized into compact bone. That's like 1/4 of the bone mass in our body. And Well, we have vascular canals as well. The vascular canals are connected, the central vascular canals are connected by other vascular canals because there's a whole network of blood vessels. And we have the osteons here. There will be another osteon here. The osteons are dynamic structures, so some of these are growing and some of these are being replaced by new osteons. So you can find lamellae not belonging to any currently existing osteon. Like remnants of previous generations of osteons. As you go closer to the bone surface, there are circumferential lamellae on the outer side, and there are circumferential lamellae on the inner side of the compact bone that run parallel to the surface of the bone. The outer aspect of the bone is covered by periosteum. Periosteum is a connective tissue layer, and it has two major sublayers, the outer being more fibrous, made of type 1 collagen, and this sends collagen fibers, thick bundles of collagen fibers projecting into the surface of the cortical bone. And there is also an inner layer of periosteum where generations of osteogenic cells reside. On the inner aspect, there is a thin connective tissue layer called endosteum. So periosteum is also vascularized. Then the whole bone actually is vascularized. So let's describe it. We have the central haversian vascular canal. We have the connecting Volkmann's canal, double N, vascular canal, the one that connects two haversian canals. We have the osteons, so this would be an osteon. We have the lamellae that belong to the previous generations of osteons that are called interstitial lamellae. Closer to the surface, we got the outer circumferential lamellae. And there is the periosteum with the outer fibrous layer, and the inner osteogenic layer, with the osteogenic cells, that will differentiate into osteoblasts, for example, when broken bone starts its healing. Together, these two layers form the periosteum. And the outer fibrous layer projects into the cortical bone with thick, sharp collagen sharpase fibers. So this is another osteon. We go to the inner surface of the compact bone, which has the inner circumferential lamella and a thin connective tissue layer called endosteum. There are also some osteogenic cells here. And here there will be the bone marrow cavity, okay? The distribution of these two forms, the trabecular and compact bone, varies in different bones of human body. So, for example, taking an example of a long bone, we know that the compact bone forms the cortical compact layer on the surface, which is really thick in the diaphysis region and quite thin on the epiphysis. And most of the epiphysis has the architectonics of the trabecular bone, where the trabecules are organized according to the trajectories of forces loading the bone. So this is the compact cortical bone. The compact bone is very thick in the diaphysis. And most of the epiphysis, the center of it, is organized as the trabecular bone. A special pattern is found on the flat bones of the skull vault, where the outer and inner cortical lamina surrounds the trabecules of the spongy bone in the middle. So this outer cortical lamina and the inner cortical lamina are made of compact bone, and the center is occupied by the spongy bone, by the trabecular. And this organization is called the diploe.